we know that the proportion is estimated through uh, P, which is equal to x over n. Okay, so for example, if we have two set of populations in which we wanted to count for male and female. So for example, we have amount of female is 50 and 85 and male is 15 and female. So if we would like to calculate the proportion of male, it will be 15 over 100. 15 plus 85 is the total. So if you would like to calculate the proportion of female, it should be what? 85 over 100. That is the proportion. Okay, so when you're talking about the proportion, so once you have estimated the proportion, so if you would like to calculate the average proportion in term of strata, so what you're going to do here, simply this number will be written as 0.15, 0.85. okay, so this is called PM and PF. So what is to be done, N1 multiply by 0.15, N2 multiply by 0.85. okay, and then this must be divided by 1 over n. Okay, so what is your n? The total population 100, and n1 is 15 multiplied by 0.15, and this is 85 multiplied by 0.85. so altogether, so could you estimate what is the number? Zero point 745. So that is the proportion. Okay, so here we have used this approach. Okay, we have used this approach with 1 over n and summation of ni. Ni is the population of one strata, and Pi is the proportion of that strata. Okay, plus, so L is basically the number of stratas you have. So currently in this example I am having 2 stratas, so L is considering 2, male and female. So we might have more stratas as well, so there will be more expansion to this summation as well. And similarly, the variance is calculated by from the same formula. Formula is the estimator formula 1 over n summation Pi and Ni and Pi, I going from 1 up to L. So L is basically number of stratas. So when we want to calculate the variance, so we will apply the variance operator. Basically variance is operator, so we will apply the variance operator over all the values. So since 1 over n is the multiple of a random variable, because ni and pi is the random variable. Okay, then this should be n square, and this ni are also constant. Pi is only the random variable. So in each of the case we will have ni square variance of p1 hat plus not ni n1 n2 square variance of p2 hat and so on. Okay, that is the expansion. So it means that your variance will be, yeah, this one, the same, the variance of pi. And the variance of pi, we already know that. What is the variance of p? Variance of p, q n minus 1 square root, sorry, not square root, without square root. Okay, that is the normalized term. Yeah, that could also be written as the same. So here you could see that the same expansion is there, and 1 minus n I over ni, that is the normalization term that usually is used when your n is small, capital N is very small, then this normalized factor is used. Otherwise there is no need. Okay, that's it. And now we can have one of the example, question number 5.12, in which we have again the same example with 3 stratas, and each sample is n1 55, n2 62, n3 is 93, and stratified random sample n is equal to 40 household is chosen. In other word, a simple random sample is taken from each stratum of sizes n1, n2 and n3. It is selected. So, and the proportion is here. I mean, this table is giving you all the information, whatever is needed. This table. So according to this table, the sample size for each stratum is given 28 and 12. So there are 3 sample, n1 and n2 and n3 is given. So out of n1, n2 and n3, you will be calculating your proportions. Okay, so you will be calculating your first proportion, p1 16 over 20. And then p2 should be 8 over 2, and third should be p3 is equal to 6 over 12. Sorry, it is 2 over 8. And lastly 6 over 12. So these are the proportions and the values are mentioned here. So the answer for each has been mentioned already here. So it means that the proportion is given already. Okay, so what is to be done? Estimate the proportion of the household viewing X and place a bound on error of estimation. So what we have to calculate? We have to calculate the proportion of the viewership altogether, because we have proportion of viewership in separated form. Okay, in stratum 1, in stratum 2, in stratum 3. So we want them to see as a whole viewership, as a type of average. Okay, So for that reason, simply you have to use the formula 1 over n. So 1 over n. So 1 over n mean 310. Then how do we obtain this? By adding all the capital N1. So we will obtain n is equal to capital N1 plus capital N2 plus capital N3. So it is 155 plus 62 plus 93. So altogether 310. So this number is 1 over n. Okay, and then we have n1 multiplied by 80%, n2 multiplied by 20% from this table, and then n3 multiplied by p3. Okay, n1 multiplied by p1, n2 multiplied by p2, n3 multiplied by p3 out of this table. So in that way, it is type of weighted average. Okay, where we are giving the weight to each of the proportion according to the its magnitude. So we are giving a weight of 155 to 80% because it is relating with the first strata, and we are giving weight the second proportion, we are giving weight 62 because it is relating with the second strata, and we are giving weight 93 to the third because it is existing in the third strata. So that is kind of weighted average, and altogether the average proportion is 60%. For example, if you take the average of 80%, 25% and 50%, it should be around, no, I'm telling it. So average of this column is 51%, which is in your opinion it should be like it is the true average, because you have the proportions and you wanted to get average of all the proportion and you're getting 50%. That is a false average. The true average will be depending upon the weight of each stratum, depending upon the weight of each stratum. So weight will be applied and the true average is 60%, that viewership. Okay, because in normal sense, if you don't have statistical background or mathematics things, so you will be having your average 51%, but this is not the true average. Your true average is 60%, which is depending upon the weight of each stratum, because in each of the population, in each of the stratum, there are different amount of population sizes are existed. So adding them together, the 60% should be there. And then the variance is very straightforward. It should be calculated. Variance of P1 is 1 minus N1 N1 P1 Q1 N1 minus 1. So we are getting 0.007. That is the variance, first variance, second variance, third variance. By adding them together, we are getting, and by solving the total variance is 0.0042. Okay, so this is the variance that is a true variance. Otherwise a false variance could also be calculated just by adding all these three variants and divide by 3. So you could get a false variance. Okay, but a true variance will be calculated through this formula and by adding all the variance. And here for each variance, so for each variance in similar manner, you could see that the weight is there. For each variance the weight is there, for each variance the weight is there. Okay, and it is divided by the square of the population. Sorry. square of the population. Okay, so that's how you get the true variance. And placing a bound on error is very easy. Simply multiply 2 with the square root of the variance, so you will get the b. Okay, so the bound on error is very simple. Once you have the variance, so once you have the variance of the estimator, then another step is to take the square root of the variance, square root of the variance, and another step you will multiply by 2 to get b, bound on error. So that is the objective of these type of questions. So it means that when you have been given this type of question, so you might be in one step, you might be estimating the proportion. Okay, so that is the proportion, and in second step you will be estimating the variance of the estimator. In the third step you will be estimating the b. Okay, so in each of the case the formulas are there. Okay, it is mentioned in this table for all these 3 formulas. This is the table which is giving you the overall. Okay, all this. So here is the formula 5.15 for sample size calculation when the proportion question is given. When your question is relating with proportion, so 5.15 is the formula that will be used to calculate the sample size. Okay, and in this formula you already familiar that Ni will be calculated through the, not calculated, it will be given to you as a strata sample size, N1, N2, capital N1, capital N2, capital N3 type of things. Okay, and the next thing is the proportion P. So P should also be given to you, and Q is the reverse of P. For example, if your P is, let's say, 65%, your Q will be 35%. Okay, 0.65, 0.35. So these are reverse of each other, P and Q. Okay, so it means that in the formula Ni is the strata sample size, population size, strata population size, not sample size. Pi is the proportion, Qi is the reverse of that proportion, and N, capital N, is the total of the all capital N1, capital N2, capital N3, and again this is the same but in the numerator. Now the only thing which is the crucial one is the AI. Okay, not that AI which is computer science AI, this is another AI. So this one is crucial one, and that one is also crucial one. The AI in the computer science is also a crucial one, but this AI is also crucial to estimate the sample size, and this AI is calculated by using this formula. Okay, this is the formula of AI. Okay, and you it is written by this way. For example, it is you could write, you see, it is written here in generalized form, it is written here. So you could write Ni is equal to NAI. So in this formula, NI is equal to N, and then this one is called the AI, all this formula. Okay. So this one is called the AI formula, which is a multiple of N. Okay. Multiple of this N is called the AI. Okay, so I'll be writing this formula here. Just let me copy, because if you wanted to calculate the sample size, you must need AI first. So AI formula is Ni square root of Pi Qi divided by Ci divided by summation Nk square root of Pk, Qk and Ck, and K is varying from 1 up to L. L is the number of stratas we have. Okay, so that is the AI. Let me write AI. Okay, and then we'll come to the and later on, what is this? Where is the recording? So in example 5.1, so already the data is given. So proportion P1, P2 and P3 is given already. Let me mark. This is the first proportion, second proportion, third proportion. So if P1 is 80%, then what is Q1? 20%. 20%. And if P2 is 25%, then Q2 is 75%. If P3 is 50%, Q3 is 50% as well. Very good. Now the cost of obtaining observation $9 for either town and $16 for the rural area. So that is C1 and C2 $9 and C3 is $16. Cost is given. C1, C2, C3 is given. And we already know about the population of each strata, which is N1 155, N2 62, N3 is 93. It is already given in the table. And we have been given also the firm wants to estimate the population proportion P with bound on error of estimation equal to 0.1. So what this information is, bound on error is B, 0.1. Okay, that this B is also given. So it means that you have all those information which is needed to put into the formula. So first of all, I'm gonna use this formula. I think if you remember all the terms, so we could directly use this formula AI. Okay, so AI mean you have to calculate first of all A1. So A1 is N1 square root of P1 Q1 divided by C1. Okay, C1, not Ci, and divided by N1 square root of P1 Q1 C1 plus N2 square root of P2 Q2 divided by C2 plus N3 square root of P3 Q3 divided by C3. Okay, so it means that for each A1, A2 and A3, the denominator will remain the same. This denominator will remain the same. So it means that you just need to calculate the numerator. For A1, A2, so for A2 it will be N2, P2, Q2, C2. For A3, the numerator will be N3, P3, Q3, C3. And the denominator will remain the same for each A1, A2, A3. It will remain the same. Okay? Because we are getting some sort of, proportion out of total. So this is the total and this is the proportion of what is AI. So could you put the values inside? So I think the answer for this one is altogether 41.241, isn't it? 41 so the answer of this is 20.66. Let me write by this way. 20.66 divided by 20.66 plus 8.949 plus no 11.625, sorry, 11.625. okay, and A1 is equal to 0.501. This is A1, and A2 is very straightforward. You just use this all values. Okay, whatever the values you have, you could use that in the denominator. In the denominator we have three values, 1, 2, 3. Okay, now you are going to calculate A2. Okay, so 8 for A2, so 8.949 should be the numerator. 8.949 should be the numerator, and denominator will remain the same. 949 plus 11.675. okay, for the A1, 20.66 will be the denominator, is the numerator. For A2, 8.949 will be the numerator. Okay, and for A3, what should be the numerator? 11.675, which is the last number, and divided by the again total 11.625. 625 949 11.625 625. So you will be getting here proportion A2 A3. okay, so what is A2? 0.217. And what about A3? 0.281. okay, so that is A1, A2, A3. Now our objective is to calculate the n, And for the n, we already know the formula, which is here. Yeah, this one. Let me copy this formula. Okay, so in the formula we have n1 p1 q1 divided by a1, n1 square plus n2 square p2 q2 divided by a2 plus n3 square p3 q3 divided by a3. So divided by n square is 310 square and d is b square over 4. So we have the b square over 4. Okay, and plus n1 p1 q1 plus n2 p2 q2 plus n3 p3 q3. Okay, so here you just need to put the values inside the formula. So p1 n1 is 155 square, p1 is 80% and q1 is 20% divided by 0.5 0.501 plus n2 is 62 square, p2 is 25% and 75% divided by 0.217 and last term is 93 square, p1 is 0.5 divided by 0.282. Okay, this is the numerator and now we are writing the denominator. So 310 square 0.1 square by 4 plus n1 is 155, p is 80% and 20% plus 62, p is 25% and 75% and last term is 93 multiplied by 50 into 50%. Okay, so what we are getting all together, n should be so it is 62.3 which is approximately equal to 62. Okay, which is approximately equal to 62. It means that n1, so n1 is equal to n a1. So n is 62 multiplied by A1 is 0.501. So almost 31. Okay, almost 31. N2 is NA2. N is 62. A2 is 0. No, 0.2. A2 17. No. A2 17. Okay, 0.217. So what is the answer? 13. And N2 is equal to N3 is equal to NA3. 62 into 0.282. Answer 17. So here is N1, A2, A3 according to the cost. So you have to pick 31 sample from the first strata, 13 from the second, and 17 from the third to get meeting with your error.